Hello and welcome to this solution video of paper 4 mechanics A and AS level mathematics Cambridge International Examinations. This solution is of October-November 2022, which was written just 3 days ago. Many people were demanding that I should upload solutions. I can upload the solution only the ones which my students write. So this was written, so it was available. I'm solving this for you. Okay, let's move on to question number 1 straight away. A cyclist is riding a bicycle along a straight horizontal road AB of length 50 meters. So let's draw this. This is A, this is B, and the length is 50 meters. The cyclist starts from rest, that means U is 0 at A here, and reaches a speed of 6 meters per second at B. V is 6 meters per second. The cyclist produces a constant driving force of 100 newtons. So if I draw a free body diagram, the forward force, which is also called applied force, is 100 newtons. There is a resistance force, that means there will be a resistive force, let's call it Fr, in opposite direction. The work done against the resistance force from A to B is 3650. So work done by resistive force is 3560. Find the total mass of the cyclist and the bicycle together. Since work is involved, let's use the normal energy equation, where work done by applied force is equal to the sum of work done by resistive force plus change in potential energy plus change in kinetic energy. Okay, work done by applied force, work is force multiplied by the distance. In this case it is 50. So force applied is 100 newtons multiplied by distance, which is 50. Work done by resistive force is given 3560. They clearly said it's a straight horizontal road. That means there is no change in potential energy. It remains at the same height. Kinetic energy change will be half. Let me write the formula here. For kinetic energy is half m final velocity minus initial velocity, and that's what we'll do. M is, we have to find m. Okay, final velocity is 6 meters per second minus U is 0. Okay, so it is 5000 equal, let's bring this to the left side. So 3560 is negative now, equal to half m times 36. We can cancel this here, 18. All right, so now 5000 minus 3560 will be 1440 equal to 18 m. Divide both sides by 18. So cancels here, and 18 times 8 is 144. So m becomes 80 kilogram. This mass of cyclist and its cycle is 80 kilograms. Okay, question number 2, A part. A particle P of mass 0.4 kg is in limiting equilibrium on a plane inclined at 30 degrees to the horizontal. So let me draw it here. This angle is 30 degrees. Okay, the mass is 0.4 kg. That means the weight will be 0.4 times 10. 4 Newton will be the weight towards the ground. And it is in limiting equilibrium. The component of this weight in this direction is always the sine component. So it will be 4 sine 30 degrees. Okay, is it smooth? It is not smooth. Okay, show that the coefficient of friction, that means there is friction also, coefficient of friction of the particle is this. Whenever this is show that, it makes our job very easy. Our target is known to us. We have to reach here. And the frictional force will be in this direction, right? Frictional force is the coefficient of friction that they are asking, mu times the normal contact force R. Normal contact force is, normal means 90 degree to the surface in this direction, and it is always, not always, mostly equal to this component which is in this direction, because they are balancing it out. There is no other force, that's why they are balancing out. This component of 4 Newton is 4 cos 30 degrees. This is sine 30, this is cos 30. That is, this 4 Newton has been broken into two components. Alright. Since it is in limiting equilibrium, that means this force 4 sine 30 will be equal to frictional force in this direction. That's why it is not moving, which is mu R. Mu we have to find, and R we just found. R is 4 cos 30 degrees because they are balancing out. So I will write here 4 cos 30. Now you can use your calculator to evaluate these. Sine 30 is half. So 4 times half equal to mu times 4 cos 30 is square root 3/2. Okay, so this cancels, this also cancels. So 2 equal to mu 2 square root 3. We want to isolate mu. So 2 square root 3 divides both sides. Here it cancels fully, here it cancels partially, only 2 and 2 cancels. So mu comes out to be 1 over square root 3, but it is not matching with what they want. For that, we will rationalize the denominator, multiply by square root 3 up and down. Square root 3 times 1 is square root 3. Square root 3 times square root 3 is complete 3, and now we got what they wanted, which is 1 over 3 square root 3, same thing as this. Okay. A magnitude of 7.2 Newton is now applied to P directly up the line of greatest slope. So let me go back to this, and there is a the diagram will change now, so I'll have to redraw this, because friction joins the weaker force. So if we are applying 7.2 newtons upwards, and given that P starts from rest, that means it starts moving up. When the body starts moving up, friction cannot be in upward direction, it has to go in this direction now. So there are two forces here now, frictional force plus 4 sine 30, which is 2 Newton. We already, let me write 4 sine 30 if for the sake of understanding. If you sometimes skip the video, maybe you're not aware why it came here. All right. So there are two forces now, and 7.2 in this direction, and everything else remains same. No need to show it. Okay. Find the time it takes for P to move up 1 meter. So S is 1 meter. They are asking us time. If somehow I find acceleration, I will get that time. For that, I should do what? I should equate these two, and we'll get the net force out of it. F net force is equal to mass times acceleration, right? And here this 7.2 is still stronger than these two forces, so it will become 7.2 minus F. We got this thing, yeah, this was square root 3 over 3, right? That was mu. So F I will write as mu R. So square root 3 over 3 R. R was how much? 4 cos 30. 4 cos 30 is a square root 3 over 2. All right, this F is done. 4 sine 30 plus 4 sine 30. Sine 30 is half. So let me again write the value of half. So what I did, 7.2 is in this direction and motion is also in this direction, so I took it as positive, and the two forces which are opposite to it, which is F and 4 sine 30, they are negative, so I put a negative outside and added them inside a bracket. And they've given the mass. Yes, mass is given in the first part. Let's see. Yeah, 0.4 kg is the mass. So let's use it. 0.4 times A is equal to 7.2 minus this complete 3 will cancel with these square root 3's because they are also complete 3 together, right? So I can cancel this. This 2 cancels with 4. So 2 plus, they are also cancelling, 2 plus 2. So 0.4 A is equal to 3.2. If you are not aware how this happened, please just put in a calculator, you will get the same answer. 7.2 minus 4 will be 3.2. So A is 3.2 divided by 0.4, which is 8. Yeah, 8 meters per second square. Now we got acceleration and we can find the time now. Acceleration is 8 meters per second square. So what do they want? They want time it takes to go 1 meter up. Okay, and it starts from rest, right? It starts from rest. So U is 0. So we can use S equal to UT plus half AT square. This kinematic equation we can use. S is 1 meter, U is 0 times T plus half. Acceleration now we got 8 and T square. So 1 equal to 2 and 8 cancel, 4T square. Divide both sides by 4. So T square is 1 over 4, and if we square root both sides, T will be plus or minus half, but because time cannot be negative, so only half second. This is the time taken by that particle object to go up 1 meter. Okay. Question number 3. Question number 3 has this setup. A particle of mass 0.3 kg. Let me draw it here. The weight of this 0.3 kg will be 3 newtons, right? 0.3 multiplied by 10 is held at rest by 2 light inextensible strings. This is string, this is one string. One string is attached to the ceiling at 60 degrees. Okay, it's there. The other string is attached at an angle alpha to the vertical wall, and the tension in the string is attached to this 4 newtons. So here we have a tension of 4 newton. Find the tension in the string which is attached to the wall and find the value of alpha. Okay, so let's focus on this mass whose body diagram I started to draw. There is a tension in this direction which we have to find. Correct? This tension in this string. There is a tension in this direction also, which is, how much they said? 4 Newton. It is 4 Newton in this direction. Any other force? No. The weight and 2 tension, they are the only forces here. But only this weight is vertical, others are inclined. So we should change them to their components. First of all, this alpha angle. Let me draw here in the drawing diagram itself, you'll understand. If I draw a line, vertical line, don't you think this angle and this angle both are alternate angles because this line is parallel to wall. So this angle becomes alpha for us. Okay. Similarly, this is 60 degree. So if I draw a horizontal line, this angle will also be 60 degrees because they are also alternate, and this horizontal line is parallel to the ceiling. That's why it is 60 degrees. So I will draw a horizontal line too and write that this is 60 degrees. These two lines, this horizontal line and this vertical line, will help us to divide this T and 4 into their components. whichever component has an angle with the force becomes the cos component. So this downwards component of T will be T cos alpha. The component on the opposite side of the force here will be T sin alpha. That's the rule. I have explained this in my previous videos as well. Now, here is the angle. So this will become 4 cos 60. Cos component again, because the angle is here. The opposite one, 4 sin 60 degrees. Right? Now we have all of them and we can form equations out of this. So first, let's equate the horizontal forces. Horizontal force is 4 cos 60 towards left and T sin alpha towards right. So T sin alpha equal to 4 cos 60. Cos 60 is half. So T sin alpha equal to 4 times half, which is 2. This is equation number 1. Let's talk about equation number 2, where we will compare the vertical forces. So 4 sin 60 and this T cos alpha, which is downwards, plus 3 Newton, which is also downwards, will be equal to 4 sin 60. Let's keep T cos alpha here and bring 3 there. So it becomes 4 sin 60 is square root 3 over 2, and then this plus 3 goes there and becomes minus 3. Okay, so this cancels also. So T cos alpha, if I use my calculator, T cos alpha becomes how much? 2 square root 3 minus 3. Let's not use calculator, just 2 square root 3 minus 3. I will use calculator later. This equals equation number 2. So whenever we have a combination of force and its angle, just divide the sine 1 by the cos 1. What I mean is this: if I divide equation number 1 by equation number 2, not in opposite direction, why? I will tell you just now. T sin alpha is the left side here, equal to 2, divided by T cos alpha, which is left side here, divided by 2 square root 3 minus 3. So the purpose is T and T cancel, and sine over cos, we know that it is tan alpha, it becomes 1 ratio. That's why we divide sine by cos, not cos by sine, because there is no cot in our calculators. So 2 over 2 square root 3 minus 3. So alpha we can find. They are asking us to find alpha, right? So they are asking tension first, but we are finding alpha first. That's fine, no problem. Tan inverse 2 divided by 2 square root 3 minus 3. And by the time I use my calculator to evaluate this, I would request you to appreciate that I'm solving this exam very quick and helping you to understand your mistakes and prepare for future exams also. When I put this in my calculator, I get 76.9 degrees and 3 significant figures. That's fine. Now, second part was to find tension as well. Find the tension in the string attached to the wall. And we have an equation for that, which is, let's use this one. So T sine, and now we know alpha. Alpha is 76.9 degrees is equal to 2. So divide both sides by sine 76.9 degrees and sine 76.9 degrees, so that this cancels here. T is equal to 2 divided by sine 76.9, which is 2.05 Newton. We got tension as well as the angle. All right, move on to question number 4. A car of mass 1200 kg is traveling along a straight horizontal road AB again. They have similar situations. A, B. There is a constant resistance force of magnitude 500 newtons. So resistive force is there, which is 500 Newton. When the car passes point A, it has a speed of 15 meters per second. At this particular point, U is 15 meters per second. And the acceleration is 0.8. And they're saying when the car passes point A, this acceleration is here. It is not throughout the journey. It is here at this point. Okay. Find power of car's engine at point A. At point A. That means not after this, at point A only. All right. So in this case, they have given us a resistive force. They have given us the speed and this. So power, they are asking power, right? Power is at a specific point, whatever is the force which is being applied by the engine or the person times the speed at that point. Okay, this becomes power. Speed is known to us, 15, and okay, that's it. And applied force, we don't know, they have not given, right? Now, since acceleration is known, we can use the formula we used earlier. F net is equal to ma, which is the forward force or applied force minus the resistive force, right? M is known to us, which is 1200. Acceleration is also known to us, 0.8. At that point, applied force, we are on the way to find out, but we know resistive force 500 newtons. 12 times 8 is 96, so 960 Newton is equal to F applied minus 500. Let's bring this 500 to the left side. So 960 plus 500 is equal to applied force, which is 1460 newtons. And this is what we will use here. So it becomes 1460 multiplied by velocity, which is 15. And if I multiply, it becomes 21,900 watts, or you can write 21.9 kilowatts. Okay, what about B part? B part says the car continues to work with this power even after that. So if the power remains same, this power remains same, and applied force and velocity will change, because we know the velocity will increase to this, and they have written here speed of the car at B is 32. So speed here is 32. That means speed is increasing, but the power is remaining same. That means force applied is reducing because velocity is going up. Okay, this is how we interpret the situation. The car takes 53 seconds to travel from A to B. So time is given to us. Time is 53 seconds. Okay, and velocity, last velocity is 32 meters per second. Show that the distance AB is 1362.6. Okay, so let's do what? Let's use the energy formula again. Okay, so first we have to find work done. We know work applied is resistive work done by resistive force, and plus change in potential energy plus change in kinetic energy. We don't know what is the work done by applied force, but we know that the power is the work done by time. Yeah, at the rate time is work is done is called power. So we can find that applied work with the help of this, because we know power, which is 21,900 from part 1 equal to this over 53. So this goes and multiplies here. So applied work is 21900 times 53, which will be 1160,700. And that's what we're going to do here. 116070 is applied work. Resistive work done by the resistive force will be, how much was the resistive force? 500, and multiplied by distance. Yeah, let me remind you again, work is force done multiplied by the distance traveled by the object. So force times distance. So this distance they're asking us to show that is this. Again, it's a horizontal road. Let me see again and show it to you. Straight horizontal road AB. That means the height is not changing again in this question as well. So it will be 0. But speed changed to 32 meters per second from 15 meters per second. Yeah. So if you remember, we have done in previous question number 1, I think, delta KE is half m v square minus u square. So half m, and the mass is how much? 1200. Yeah, yes, 1200 is the mass. So times 1200, 32 square minus 15 square. Done everything known except for the distance. So 116070 equal to 500 d. 2 multiplies here, 600. 1024 minus 225 will be 799. Oh, sorry, it is not plus, it's multiplying. This 600 will multiply with this, so 799. So let's keep 500d here and bring this whole thing to the right side. So 116070. Oh, there are 2 zeros. Okay, I forgot to transfer it well. Minus 479400 equal to 5d. Divide both sides by 500. So that it cancels and we get distance, and I'm sure the distance will be 1362.6. This concludes the first part of this exam. I will be uploading remaining 3 questions very soon. Please support this video, share with your friends, and like this and subscribe to my channel. I'll be coming up with the part 2 very soon with your motivation. Thank you so much.